what most people do is they jump to kind of that insight step. So they explore the data, trying to get these interesting insights, then project stops. Well, if you think about CRISP DM, you've got business understanding, then data understanding, data prep, and then modeling.
What's up, everybody? Welcome to the Artists of Data Science podcast, the only self-development podcast for data scientists. You're going to learn from and be inspired by the people, ideas, and conversations that'll encourage creativity and innovation in yourself so that you can do the same for others. I also host open office hours. You can register to attend by going to bit.ly/ADSOH. I look forward to seeing you all there. Let's ride this beat out into another awesome episode. And don't forget to subscribe to the show and leave a 5-star review. Our guest today is an independent data miner, trainer, speaker, and author. He's got a wealth of consulting experience in statistics, predictive analytics, and data mining. He's a sought-after speaker who routinely leads workshops at conferences. He's given keynote presentations at many international events and is an award-winning instructor for UC Irvine's Predictive Analytics Certificate Program. You may recognize him as the instructor of 13 courses on LinkedIn Learning, where he's taught over 250,000 learners through his courses. Or you might recognize him as one of the co-authors of one of 6 books, including SPSS Statistics for Dummies and IBM SPSS Modeler Cookbook. Since serving as a VP of Analytics for a small consultancy, his consulting has shifted emphasis towards helping his clients build and manage their analytics teams. So please help me in welcoming our guest today, author of SPSS Statistics for Dummies, Keith McCormick. Keith, thank you for taking time out of the schedule to be here today. I appreciate you coming on the show.
I look forward to it.
So Keith, talk to us about how you first heard of data science. What drew you to this field?
Well, of course, it wasn't really called data science at the time. It was that famous Sexiest Job article, and that's when we all started calling it data science. I started doing this kind of work, depending on how you start counting, in the mid-'90s or the late '90s. I was doing more traditional statistics in the mid-'90s, and then I relocated to North Carolina, where I still live, figuring that I would do PhD work. But, had to pay the bills, so I was looking for part-time work. And I knew SPSS statistics quite well. So I got an opportunity to start teaching their introductory classes. And next thing you know, I was heading up to Arlington, Virginia frequently to teach those classes. And then year after that, I was teaching 40 plus weeks a year all over the country. So obviously grad school didn't work out. And I was a software trainer for more than 10 years, almost nonstop.
So most of that training and teaching that you're doing, that was for companies and at corporate kind of events, or was this in universities as well?
Oh, somewhat all of the above, but I was a contract trainer. So a number of my colleagues were full-time, but I was just kind of brought in by the day. But I was working directly for SPSS Inc., teaching what initially were introductory classes and then more advanced ones. So to answer your question, it was really somewhat varied because I would be in an actual SPSS office with people from all kinds of different companies, but sometimes I was sent directly to the company, and sometimes they were more academic settings. I remember, for instance, having a group of researchers at CDC, and naturally, I wouldn't have known their specialties nearly as well as they did, but it was so fascinating to have that job because I would meet these experts and be showing them how to use the software.
So you mentioned you've been in the field since the 90s, and it wasn't until recently that it became known as like the quote unquote sexiest field. How much more hyped has it become since you've broke in?
It's funny because I spent weeks trying to figure this out a couple of years ago. It sounds like a silly thing, right? But what was happening is conferences said, Keith, we really enjoy the workshop that you did on Introduction to Predictive Analytics, but could you rename it the Introduction to AI? Okay. And I'd be like, really? We're just going to change the title slide? We're not going to change the meat and potatoes of the course. So I started to become really fascinated with why everybody wanted to start calling things AI that just a few years earlier we had called machine learning. And naturally, a lot of things really have changed. But what I concluded was that 2012 was really the big year where the dominoes started to fall, that we're calling everything AI now. Because that was the year that Hinton and his team won that data visualization award with the first neural net that had a bunch of layers in it. And, deep learning was basically born. And it took a couple of years before that moved from the academics to everybody else. But that's really why we're calling everything AI now. So I think the trick is to remind people that affects things like autonomous vehicles, medical imaging, Amazon Echo. I have one right here, so I don't want to call it by her other name. She'll start speaking to us. All that stuff has been massively changed. But the day-to-day stuff that I've been doing all these years, loan defaults or insurance fraud, hasn't really changed. It hasn't gone through this dramatic change over the last several years. It's really been those other areas.
So I'm wondering, it might be an odd or naive question here, but I'm wondering how much of an impact the use of tools have had on the name of the field. Because when I was coming up in grad school, it was primarily SPSS, SAS, and highly specialized software for doing the statistics and stuff. And since, recent memory, it's been moved into like Python, which is more general purpose programming. What are your thoughts on that? Do you think having this technology, I guess, democratized, for lack of a better word, had any impact on it being called AI?
I think you're onto something. I think there's definitely something there. But, when you think about R, how long has R been popular? Maybe 15 years was kind of really starting the rapid rise of R. But, that didn't prompt the change, did it? Right? So I think what was driving R was open source. But I think there's a connection between the 2012 event that I was just talking about and the Python piece. Python's been around for many years. It's a great language, but it was always thought of as a general purpose programming language. Like much of the Google search engine is written in Python. But when I was starting out, certainly, even though Python existed, it wasn't associated with machine learning like it is now. So I think if you went back and looked at Google search data, I bet that TensorFlow and everybody calling in Python taking over R and everybody calling everything AI is probably around the same time.
Excellent project idea for anybody that's listening. So
it would be very cool. That would be a fantastic blog post. I would love to read it.
So you've got a great philosophy about the effective use of machine learning and analytics, that in order to make it work, we need to have effective teams. So talk to us about what an effective team looks like and how do they operate?
Yeah, I'd be glad to. I am passionate about this one because I think that most client organizations that I encounter, what they're missing, what prevents them from being effective, is effective analytics middle management. And by that I mean, for one, nobody can figure out who the data scientist should work for. Should they report to IT? That's probably true 30-40% of the time, but that puts a certain spin on things. Do they report to the line of business? Sometimes that happens. Maybe it's marketing analytics is the first use case, so they end up staying there and they're reporting to the VP of marketing. You'll see that. It's not at all uncommon. Probably about 10-15% of the time, data scientists will report to the CFO. And then, of course, you get the whole center of excellence model. So that's one problem that has to be overcome. But very frequently, as a consequence of that, data scientists aren't reporting to other data scientists. And you can imagine what happens then, right? People feel misunderstood. And, that's why I think that even though it's a hot job market, at least that's the reputation, right? That it's a hot job market, that then data scientists don't stay. Sometimes 11 months, you'll look at a lot of folks in LinkedIn, they're actually quite successful, but they've had 5 roles in 5 years. So something's broken because obviously they're getting that promotion, they're getting that new role, but they're not staying. And if they're not staying, I think there's a reason for that. So I think probably you need to have data scientists reporting to someone that really understands them, that has an appreciation for data science if they're not a data scientist themselves. And then you have to sort out who that team is going to report to.
So you also talk a bit about diversity on teams. Talk to us a little bit more about what you mean by that.
Yeah, I think the problem is that sometimes we get obsessed with technology, like we've already been mentioning, Python. I think also we can fall into the trap of thinking Python is one thing. I mean, scikit-learn, TensorFlow, all these different packages, people can have different specialties within that. We also think that, open source is open source. Well, try to tell an R programmer to leave their R that they're comfortable with, and now they have to do everything in Python. They'll be able to make that leap, but nonetheless, there's a lot of specialties within open source. So the problem with a lack of diversity on teams is if you decide up front, everybody's going to use Python. That's the only option. So now you tell HR that, and now you get coding exams and all that kind of stuff involved. So now a fabulous candidate comes around with 10, 15 years of healthcare analytics experience, and maybe they do okay on the Python exam, but they don't ace it for exactly the reason that you mentioned, that 15 years ago, they would have been learning something else, right? So they demonstrate competence in there, but they don't ace it. And then next thing you know, you have systematically eliminated anybody with more than 5 or 10 years worth of experience, which is not what you set out to do. So those young data scientists, are they contributing to the team? Absolutely they are. But do you want, in a 5 or 6 person team, do you want everybody to be a clone of each other? Go ahead and grab that person who has that amazing Python background, but then someone else who maybe is a little bit weaker in Python because they learned in SAS, let's say, but they've got 15 years of experience. So that's really what I mean. It's really from the journey that they've taken to the job that they have a diverse journey there. Also, you prevent groupthink if people have different backgrounds.
Yeah, it's a very, very, very important piece. Talk to us about how groupthink can inhibit or limit team effectiveness.
Well, I've got one specific thing that always seems to come up that drives me a little crazy, to be honest, right? There's this assumption. Now, I've already mentioned from my background, and you've mentioned, like when you were starting out, that not that many years ago, it was more common that people would be learning this kind of stuff on predictive analytics workbenches. But as an undergrad, I was a computer scientist, so I'm not anti-code by any means, right? But there's a bit of a myth around this that drives me a little crazy, which is, wow, if we just force everybody to use Python, that the reason that we're doing that is that any code that they write while they're prototyping a model or putting a solution together is inherently deployment friendly, because code by its very nature is ready and easy to deploy. And of course, that's nonsense, right? Because you always have to rethink things between a prototype and putting it into production. So the notion that you're going to dismiss anyone that's using any tool other than coding in the same coding language that the team has adopted, you're working off a false premise, in my opinion.
You mentioned a little bit earlier right here about hiring and retention in analytics that is broken. Talk to us a little bit more about how it's broken and what can we do to fix it?
Well, of course, part of the reason that it's broken is that we get these crazy job descriptions, and I know that you've spoken to other, guests about that. But then, what's crazy is the behavior that drives. I think one of the most common pieces of advice that people exchange on LinkedIn, a platform where I'm quite active, is, just ignore the job description because we all know the job descriptions are crazy. Well, it seems to me there's an inherent flaw there if the entire data science community recognizes that the HR job descriptions are nuts and therefore everybody should ignore them. So then it's broken in that sense. And then another piece that I'm passionate about is, and I'm sure they're related, is that too few organizations consider hiring from or promoting from within. Now, as passionate as I am about statistics and that's an important piece, it's an important but small piece. So I find very often folks coming from IT or BI become great data scientists, but then they don't have all the check boxes in these crazy job descriptions, so they're dissuaded from applying, and that's one of the reasons that they leave, because they're doing Coursera or reading data science books on their own, whatever it might be. They know the organization, they know the data. They go and they say, wow, I really want to apply for this data science job. Well, you don't meet all the criterion. Next thing you know, they're gone, getting an entry-level data science job at another organization rather than staying. So we have all this turnover, and I don't think it's necessary.
If we were to distill down the checkboxes into a few essential pieces that should be common amongst all data scientists in the field, what do you think those checkboxes would be?
Well, I think what's happened is we put so much emphasis on the coding that there's this huge gap between running the code that creates something simple like a decision tree and knowing the basic foundation and concepts of how the tree is growing and how to interpret it. So for me, just absolutely bedrock basic stuff is, do folks, this is going to sound so simple, it would seem obvious. Folks should understand decision trees like CART and linear regression. And everybody's going to say, oh, I know that. But do they really? Regression in particular. I remember when I did relocate down here and I thought I was going to do a PhD, the topic that I thought I was going to pursue was psychometrics. So what I was doing is, I obviously had to get stats out of the way, but it was going to be psychology and statistics in a blender, basically. So I had some stats background already. So I audited the introductory stats courses just to get them off my plate before enrolling. And naturally, as I explained, that never happened. But those first two courses were basically a regression course. But this was a graduate level course. And for 10 months, we did nothing but regression. So this idea that somebody's copied and pasted some code from GitHub and they taught themselves regression in 20 minutes is just nuts. So I really would say those two topics are the most important. It seems like a short list. But if somebody's really mastered those two things, I'm already kind of liking them as a candidate. And people would say, wow, Keith, you're talking about stuff that's either over 100 years old or in the case of CART, it's since the early 80s. Fine. But the same guy who invented CART also came up with random forests. And his work also led indirectly to XGBoost, right? So I really want to know that they know those basics.
Yeah, it's about that, the principles, right? Understanding the principles from a intuitive kind of level. Like you master this seemingly simple concept or small concept in a much larger body of work. It sets the foundation for you to be able to go learn more and more complex stuff on top of that. Agreed. Yeah. And I would say from the statistics side of the house, I want to know if they know when to trust and when not to trust the data. I'm really big on that, So if I ask them, this is the kind of thing you would perhaps ask as an interview question, to a candidate. If tell me about a time that the data seemed to tell you one thing, but then the truth ended up being something else. If a serious candidate has never experienced that, I've got real doubts about what's going on because they're probably just not bringing the necessary skepticism to the job if they've never had an experience where the data led them down one path and they said, uh-oh, the data is actually, this other thing is what's really going on in the population. Yeah, I'm excited to dig into that. So if you're listening, hang around. We're going to get into this topic a little bit later. For someone who is the first data scientist in an organization and they're responsible for building up the data science practice, what are some of the challenges you would see them facing and how could they overcome these challenges?
This is a tricky one because, of course, I'm coming at this as someone that's been an external resource for virtually all of my career, okay? I think that a lot of organizations do this too quickly. In fact, I was asked by, I don't know if you've ever heard of TDWI, they do conferences and so on, the Data Warehouse Institute. But I was asked by them to do a webinar once, and it was called Your First Hire. And it was a whole hour on this topic. But the basic premise was what organizations figure is that they just hire one unicorn and give them a head count, they'll be fine. But it puts that person in an impossible situation because they're arriving with the budget for a team, but no team. Well, how can that person arrive, get to know the organization, get to know management, get to know the data, in the organization, the challenges that are being faced by the organization while running around trying to deal with HR to hire a team, I think that's a recipe for disaster. So I think what's probably better, perhaps self-serving again as an external resource, right? But I think what is better for most organizations is bring in an external resource to help with a specific project and try to find existing talent within the organization to collaborate on that project. So one thing I really don't like at all is when organizations use an external resource and they throw the data over the fence and then they just get the solution delivered, on their desk. That's a nightmare, right? But if you bring in the external resource and part of their responsibility is to mentor internal talent, get through that first project. Might only take 6 months, 12 months, whatever it might be. Now you're in a better position to figure out because now you have some talent that you've identified internally that would report to that new data scientist coming in. So they're not coming into a team of zero. They're coming in with a couple of folks that have already been mentored on a project. I think that's the better bet because otherwise it's really a very difficult situation to be all alone on a team that exists in theory but does not yet exist in reality.
That question was very selfishly asked for myself because I am in that exact same situation.
At the risk of putting you on the spot, are you finding it as challenging as I described?
It's definitely challenging, but I'm really liking the support from the organization to make it happen. So, but yeah, everything you've outlined is 100% true, and I find myself in this situation. Boss, if you're listening, I love all the support you're giving me, though. So let's take our...
I'm going to ask a follow-up to that, if I could. Is my observation that there's always good internal talent there also true in that case? And it sounds like your organization really is supporting you in that way. Have you found that you're able to grow your team with at least some internal talent and not have to reach outside for everything?
Yeah, so I've been able to tap into some borrowed resources from some other cost centers and rope them into projects and get them to help out. And I'm a big fan of remixing talent because it just helps people with their, they could be in chapter 2 of their career, chapter 3 or 4 in their career. And they've got all the skills, but they just need to think about how to apply them in this new way, in this new context. So yeah, I'm all for remixing talent. I think that's awesome.
You've put your finger on one of the best ways, I think, to do that, which is keep the existing internal talent in their current role, but have them have a temporary dotted line to the project during the lifetime of the project. Mm-hmm. That's absolutely the best way to do it. Because then I think that before someone contemplates leaving their current department and joining the data science team, they should never do that until they've done a project from start to finish as a borrowed resource. Then you make the decision. Because think about it, you don't want somebody to officially sever their relationship with a previous relationship, let's say the IT team, BI team, or whatever, get through their very first project and then regret it. That's just nuts. Why do it that way? Have them be a borrowed resource, even if it's only half time. Then at the end of that first project, have a sit down and say, where do you want to be in 2 years? Do you want to be on this team? Or do you want to stay where you are? Do you want to occasionally be a borrowed resource?
I love it. That's absolutely the path we're taking at my current company. So I'm glad we're a bit of validation there. I like that.
Yeah, good for you, because I'll tell you, it's not the most common scenario. I probably see it maybe 20, 30% of the time, but it's absolutely what I've experienced to be the most successful way to do that.
Awesome. So taking the conversation a little bit of a philosophical direction here, talk to us about what you think the goal of analytics should be. Whenever
I'm asked this, I always give a similar answer, and it may seem technical, at first, not to us and our immediate audience, but sometimes if management asks me that, they're initially taken aback by the answer. I always suggest that when someone's trying to vet projects, all projects that the data science team might be facing, to take this concept at least out for a spin and see if it fits the problem, because it fits the problem most of the time. And that's to ask whether or not what you might be facing is a binary classification problem. Are you trying to make a yes, no? Are you trying to provide a yes, no answer to some decision? Because so frequently you are. Like in predictive maintenance, whether or not you have to take something out of service for unplanned maintenance, or whether or not you are afraid that someone is going to default on a loan. So there's some intervention strategy like the offering of a refinance or something like that. Or a potential fraudulent claim gets routed to the investigative team. And again, it sounds perhaps overly simplistic, but the reason that this is so powerful is that if you can frame the question in this form, you have massively increased the likelihood that the model will be deployed, because that scenario that I've just described is so deployment friendly. I've never sat down with an executive and talked about whether we can frame it that way for 15 and 20 minutes and not have some positive outcome. We either conclude that we can indeed, then we're off to the races, or we conclude that it's more complicated in some way. And maybe it's more complicated in some way that we can address. Maybe it's so ill-defined and complicated that we actually step away from the project and say, well, maybe this isn't the right project to do because we can't even agree upon what we're trying to accomplish.
So another philosophical question here about the use of insights. So what do we use these insights for, and why all the rage about them?
Well, I mean, who doesn't like insights, right? I was just chatting with somebody earlier this week, and the way they phrased it, very common phrase, actionable insights, right? But what do people usually mean by that? It means that you look at the data, kind of poke around, explore it for an indeterminate amount of time. These days, it's usually for 2 weeks because that's the length of time in a sprint in some organizations, right? Which is we could do a whole hour on just sprints and agile, and to what degree agile aligns with predictive analytics. So that's a huge topic, but you can't, sometimes it's hard not to mention that's out there. And in a lot of organizations, for them, agile just means that every 2 weeks we have a meeting. It's a super casual thing. And colleagues of mine that are really well trained into agile would say, no, that's not agile. That's nuts. But nonetheless, let's say you're in an organization that's really all about the sprints. So you give people the first 2 weeks, and the goal of the first 2 weeks is just see what the data is telling us. We'll call it a POC, we'll give it a fancy description, but really just kind of poking around the data. We make a discovery or two, throw it in a slide deck, have a meeting with management, and we're supposedly have reached some kind of interesting milestone. The problem I have with this is you just kind of go in circles, and when is that thing going to end? It's almost like years ago playing pinball or something. It's like if you do get an actionable insight in the first 2 weeks, then you win a bonus round and you do another sprint. I would much rather have someone try to develop a deployable model and get the actionable insights along the way. That I think is a whole lot more productive, because I want to have ROI. I also want to have some sense of the scope of my project. So the problem with me is that insight all by itself is too unfocused. I like the insights, but I want my project to be more than just insights. And I'm definitely in the minority on that one.
Talk to us about the goal of achieving a deployable model. Once we've achieved that goal, then what?
Well, I mean, you go live with the model. So let's say it's insurance fraud. Then every month you are generating a list of claims that should be investigated that go to the investigative team. And, something that people forget, it's obvious once you think about it, but people really do forget this, is that existing systems were already in place. It's not like the investigative team was waiting for the model to be done. They were already doing that. So this is another reason why I love the binary classification, because what you're really doing is you're marrying this new propensity or risk score that you have with existing business rules. And that's why in CRISP-DM, for instance, the evaluation phase, which, and I know a couple of the authors pretty well, they nearly called the evaluation phase the business evaluation phase, because that's really what it is. You get this model, you take it out for a spin, and it could take months. I mean, investigations might take a couple of weeks to complete. So for 6 months, you might be in this evaluation phase, checking to see if you've moved the needle in the right direction. That's very different than making some discovery like, wow, we've discovered some new kind of fraud, and you put it on the slide deck, and then there's either some new policy or you socialize that within the organization. How can you measure the impact if the insight was delivered in the form of a PowerPoint slide, right? But If the insight comes in the form of a risk score, which is married with your business rules, you can measure almost to the penny. In fact, you probably could measure to the penny exactly what the impact of that deployed model was over the months that you're measuring that impact. So it's a totally different world.
Absolutely love that. Thank you for that. What's up, artists? I would love to hear from you. Feel free to send me an email to theartistofdatascience@gmail.com. Let me know what you love about the show. Let me know what you don't love about the show. And let me know what you would like to see in the future. I absolutely would love to hear from you. I've also got open office hours that I will be hosting, and you can register by going to bit.ly/ADSOH. I look forward to hearing from you all, and I look forward to seeing you in the office hours. Let's get back to the episode. What are some things that we need to monitor and track once we've got this model deployed and it's out there in the wild? What are some things that the data scientist should care about and should look at? And on the flip side, from the business understanding side, what are some things that they would care about?
Well, one of the things I want to briefly revisit is when we were talking about, teams and existing internal talent and borrowing talent from other places. One of the real world situations that I encounter quite often is how can we utilize somebody like intern that maybe we're going to have for 6, 8, 10 weeks. And if you've ever managed a resource like that, it's really tough. It's like, gosh, how am I going to get them up to speed? And then next thing you know, they're gone. Well, monitoring is the perfect way to utilize a temporary resource like an intern, because it's tedious work on one level, but it's also important and therefore kind of interesting on the other, especially if you're only doing it for a couple of months. Because what you're basically doing is you're checking to see what would the business rules have said in the absence of the model. What did we investigate because the model said so, but the business rules didn't say to do so? And you're basically doing some simple arithmetic, but that arithmetic is giving you some really important numbers. And tied to this is that people get mixed up about why models degrade. They go, yeah, we've heard that models degrade, but we're rebuilding our model every night or every month or whatever. So our model's not degrading. No, your model is still degrading, even if you're automatically rebuilding it. And the reason is that the model is only one step in a long process. You're also making assumptions about what data is relevant, what variables are used in the model, and that all-important feature engineering that we're always talking about as data scientists. So those decisions eventually degrade, even in the presence of an automatic rebuild. So somebody's got to keep their eye on the monitoring of those models. So years ago, what used to happen is one person would wear all the hats. So you'd have your data scientists. They were usually alone 15, 20 years ago. They were often the only one. And then they just often wouldn't monitor as carefully as they should because they're in the middle of a new project right now. So I think that once you've got 4, 5, 6, 8 or more models cooking, it's really great to grab somebody from IT that aspires to go into data science. Maybe they're in their first career job. They're just starting out. The kind of person who has the stack of data science books on their nightstand, and say, okay, for about a half day a month, you're going to check these 8 models. You're going to check to see if they're generating the logs they should. Think about it. You could have a model that's pulling from 8 or 10 different sources. One of those sources could go down, and the model's still kicking out scores. If you're not checking that once a month, that actually could go on for quite a while, but depending on how you've set it up to give you warnings. And I've worked with clients, one in particular, really, really striking. worked with a client that they had a model that had been running for about 15 months. I read the documentation that the consultants, it was an external resource, had done to create it. Seemed like a really good model to me. They said, the sales team just doesn't trust the model. And I said, well, did it just drop off a cliff, or was it slowly getting worse? Said, well, I don't know. No one's checked that since we launched, 15 months ago. What could be more fundamental to diagnose the problem than if it slowly degraded or just suddenly it was like the lights going out? And boy, they were so stubborn about it because they did not want to try to, they just said, I don't care what went wrong, just fix it. It should have never happened because if they were just checking a few minutes each month.
Thank you very much for that. Some very valuable information. I know the audience is going to love that. A lot of good takeaways there. So continuing on this kind of thread here, can we talk about how to define, track, and measure ROI of an analysis to make sure that the work we're doing is actually delivering value for the business?
Well, this is a little bit tough to talk about verbally, right? Because in a sense, it's so visual. But the way that I would have people picture it is, as data scientists, we spend a lot of time during the modeling phase thinking about confusion matrices, our true positives, true negatives, false positives, false negatives, right? And I think everybody's familiar with that. So what it really comes down to is trying to quantify financially, because, even a nonprofit, I have one colleague in particular that's always reminding me, nonprofits don't have ROI. Well, but if you're saving labor, for instance, you can turn that into salary, so it really is money most of the time. But for all of those four possible outcomes, true positives, true negatives, false positives, and false negatives, you should be able to associate some kind of monetary amount. And that's the, without short of, walking through a specific example, that I think that alone gives people a pretty good idea of what it's like.
Yeah, absolutely. What are some steps that we could take then to turn a business problem into a data science research question?
Number one, again, I think would be posing the question, can this be a binary classification problem? I'll tell you what frequently happens. This is potentially a big topic too, but senior management will usually think what they want is time series forecasting, because that's what they learn in school, especially if they're MBAs. They're more familiar with time series forecasting, which, everybody can just picture looking at a stock data, IBM price fluctuating or something like that. That's what they think they want. They think they want it at a high level. So usually you just have to kind of gently push in this direction that what is more actionable is what a lot of folks in data science call a micro decision. Not trying to forecast how many frauds we'll have last month, but whether this claim ID is associated with fraudulent activity rather than in the aggregate. Because think about it, senior management, they're usually managing in the aggregate. It makes sense. That's what they do. So this gentle introduction to the notion of a micro decision, I think, is really kind of the wake-up call for them. And then, in fact, it leads to a broader problem, doesn't it? Is that we have to find a way to briefly introduce executives to be able to think like a data scientist, so that both senior management and the data scientists can meet halfway. That's where that analytics middle manager really is. But if you can get senior management to think in terms of micro decisions, the rest starts to fall into place.
So you've got a tremendous career working in data science consulting. Talk to us about what the difference is between working for a regular organization and working as a consultant.
One of the things that I love about, I just kind of on a personal note, like what the day-to-day is like, I love the fact that I've worked in so many different, industries. I did a gig with a regional casino once. That was interesting. So I've never worked with the big casinos in Vegas. I have friends that, you can guess the kind of work that you do, loyalty programs and so on. I did a brief gig with the Navy SEALs. I just think that's always so funny because it's so unexpected. It was looking at personnel profiles with text mining. And I actually was in the Army when I was in my 20s. I was in the reserve. So, I briefly had a clearance, but it's not something that I've maintained. So I couldn't look at the personnel records, but I taught them how to use text mining software. And we talked, we went to the whiteboard and we talked in the abstract about these records, even though I couldn't examine them personally. But, that's just tremendous variety, right? And then there was a project that was about staged accidents that almost certainly had kind of a organized crime aspect to it. Because doing a stage accident is a big, complicated thing. You're faking invoices for MRIs and all kinds of stuff. So it almost certainly was organized crime. So on a personal note, I love the variety that's involved. But switching back to contrasting that to what life would be like as a data scientist on the inside, I think that one of the challenges, it seems like a good thing at first, but I think it's actually a challenge to be overcome, is that as an external resource, there has to be this process where the client wants the project done, you're trying to determine the scope, and you're working up a contract. And having done dozens of these, I can tell you it's not writing contracts and going through that sales process is not the most fun part of the work. And it's also something that a lot of young data scientists probably aren't ready for if they were to be a freelancer. But think about that compared to working with an organization, as we were just talking about a few minutes ago. That process never happens. So a lot of times the process of deciding, is this going to take 12 weeks or 20 weeks? Is it going to be 3 people or 5 people? This person, this subject matter expert in another department that I really need, has it been reduced to writing that I have access to them 1 day a week? You know what I mean? It's never reduced to writing. It's never thought out. So I always have that contract to go back to as an external resource and say, hey, we kind of agreed upon this a few weeks ago. We either got to stick to the plan or modify the plan, right? I've got something to refer to. And I think internally that step never happens, which would seem to give you freedom. But sometimes halfway through the project, you might wish that you had agreement on those issues.
I was wondering if you had any tips for people who are trying to maybe break into data science, but do it through freelance work.
This is tricky because, and of course, this is the way that I've done it all these years, and I've really enjoyed it. But what makes it tricky is that if you reflect back on my career, I was fortunate in that by the time I started consulting, I had been doing software training for quite a few years. So I could refer to that experience. And when IBM bought SPSS, it was IBM themselves that sent me on my first few consulting gigs. So I absolutely encourage people to do it because I've loved the freelance aspect of my career. I would never change that decision. But the trick is, in the current environment, with so many certificate programs and boot camps and things like that, I think that probably before someone sticks their toe in the water, they want to be able to establish themselves a little bit in some way. So if they're working within an organization, in other words, if they aspire to be freelance, but they currently have a job, then I would want to be the kind of person that we were talking about a few minutes ago that gets assigned to a project in a visible way. Because certainly no one, otherwise, how are you going to do it if you're going to be freelance? At some point, you have to do your first project, and you probably can't do your very first project as a freelancer. You have to get that credibility somewhere. Another one that I'm a big fan of, and I wish I had done a little bit earlier in my career, was writing the book. The first book I wrote was 2013, so quite a few years ago. But when you think about it, I was 15 years into my career. And I know a lot of data scientists who took that step earlier. It's nights and weekends, you got to log the hours, and most people aren't going to make very much money from the book, but it's a huge way to establish credibility. And LinkedIn Learning asked me to do a course on related subjects. It was actually a lot of fun to do, side hustle for data scientists. And one of the specific recommendations that I made in the course is trying to be a technical reviewer for a book. Because that's somebody, literally, you could be a day out of undergrad, right? Or if you were really gifted undergrad, you could do it while you were still an undergrad. Because what a technical reviewer does in a technical book, whether it's an R book, a Python book, an SPSS book, or whatever, think about the huge volume of books that O'Reilly and Pact and all these other companies put out every year. The role of a technical reviewer is to basically check the code, check the steps. It's almost like being a beta tester for a book. But even though, the pay's not, you're not going to retire being a technical reviewer. But you can list that you were in that role, and you're not on the cover, but you're in the credits for the book. And I think if someone did that just once, they would have just a little bit more leverage when they went to submit a book proposal to write the book themselves. Now you've got a little bit more credibility, right? You go out to that client, because what's going to happen when you try to do your first project freelance? People are going to look you up on LinkedIn. They're going to, do whatever. Sure, winning a couple of Kaggle, doing, not winning literally, but, doing well in a Kaggle competition might be some credibility. But there's something about being involved with a book that really puts a client at ease, that you know what's going on.
That's some awesome advice. Thank you for sharing that. And I actually didn't have any clue that there's a course on LinkedIn Learning called Side Hustle for Data Scientists.
Yeah.
So I will be sure to link that to the show notes. That is amazing.
My acquisitions editor loved that title. Yeah.
Oh, yeah.
Well, we both did. But when I said, wow, is there anything in the library on this subject? I said, not all data scientists have salary jobs. He goes, no, there is nothing yet in the library about that. We should do something about that. So I worked up a proposal. We both liked it, and it was a lot of fun, actually.
That's awesome. So taking another philosophical turn here, talk to me about what it means for you to be a good leader in data science, and how can someone who is an individual contributor embody the characteristics of a good leader without necessarily having that title?
Well, everybody kind of develops their own leadership style. And although my military career was fairly, brief, this was something we would talk about. I mean, I don't know if everybody knows this about when you're on an RTC scholarship. You're just a college student like everybody else, but like one night a week, you have to take these Army classes, and they're, mostly on leadership and so on. My leadership style has always been very much about protecting my team. That's just always been my emphasis. So when in an analytics middle management role, the number one thing that I'm trying to do is make sure that my team is protected against just kind of random bandwidth filling ad hoc stuff. It might even sound kind of silly, like, well, of course you don't want to do that. But think about how much pressure, how much tremendous pressure, frankly, is on a data science team lead not to accept every project that comes along the pike, right? So project lands on your desk. One of the team members just finished something, perhaps, so it's obvious that they have some bandwidth or they have some time. But then it's something like, let's say a dashboarding project or something. There's tremendous value in that, right? But if that person was hired to do predictive analytics, they don't want to be on a dashboarding project. And if you don't push back, however diplomatically and gently you have to protect your team against that, next thing you know, you're going to have a data science team that's basically like a help desk that does everything that comes their way. And the team's going to be frustrated and they're not going to be happy. So, if I'm running a predictive analytics team, one of my number one things is making sure that we're spending our time doing predictive analytics, because this other stuff might overlap with our skill sets, but it's not going to show that ROI. And if I'm not demonstrating ROI, I'm not positioning my team the way that they should be for lateral moves or promotions or their next opportunity.
I love that. That's an excellent leadership philosophy. Definitely going to adopt that one. So another philosophical question here. Is statistics the same as data science?
Well, part of the problem is none of us know what data science is, right? And by that, I mean it's a puzzle that we haven't figured out yet. The term is being used in so many different ways. So something I think that hasn't come up in conversation is that for about the last year, I've been involved with an organization called IADS. It's we can put that in the show notes as well. But I encountered them at the KDD conference last year in Anchorage, and some folks may know the name Usama Fayyad, who was one of the original chairs of the first KDD conference and helped coin the phrase KDD. right? So he's been around for a long time. He also has another interesting distinction. He was the first CDO ever. He was the first person to hold that title when he was at Yahoo. Anyway, he and a colleague, Hamid, who I also know and work with, they were presenting about a survey that they did of data scientists, trying to figure out how mid-career data scientists describe themselves, and somewhat all over the place, but they're trying to figure that out. So they're working with employers, applicants, universities, boot camps to try to define all this stuff. So there's no question that statistics is part of data science, but there's also no question there are some people that self-describe as data scientists who aren't particularly interested in statistics at all. So I wish I could give a better answer than no one's figured it out. I think that knowing statistics is fundamental, even to machine learning, much less a broader topic, data science. But there's no question that there's some people that go through some kind of a program that's called a data science training program and then call themselves data scientists and have minimal, if any, stats background. I don't think they need to have a lot, but I don't think you can do data science without some stats.
I 100% agree with that, not just because my roots are as a statistician, but for the reasons you just said. Like, how can you do machine learning without really understanding statistics? Thank you for sharing some insight on that. So you've got this awesome course that I've spent earlier part of this week going through, and I really enjoyed it. And it was the non-technical skills for data scientists. I was wondering if we can walk through some of these non-technical skills that you talk about in your course. One that I really enjoyed, we'll pick a few here, but I wanted to start with this: embracing ambiguity. Talk to us about what that means.
Yeah, so, obviously, all of these are inspired by my consulting career and what I've grown to learn is important, about this. But this one in particular makes the, top 10 or whatever number I offer up in the course. I remember a number of the names that I chose to represent these traits. But when I'm teaching workshops, I'll often have folks come to me in the break. I understand why they might get, frustrated. But usually the question will come in this form. It'll be, wow, I'm really enjoying the workshop, Keith, but I've been trying to write down the steps that you used to solve problem X. And I'm kind of having trouble because I feel like I don't have a recipe here. And next time I face a problem like this, I want to be able to follow the exact steps so that it will be easy, right? And I say, well, the reason the steps weren't clear is because there is no cookbook here, There is no recipe. It's about figuring things out. I've always liked, it's a really old TV show now, Columbo, but for people that haven't seen it, I'm sure they've all heard of it, but if you're not a fan, you might not know that he pretty much knows who committed the murder within the first 5 minutes. The show isn't about him figuring out who did it. The show is about him trying to establish the evidence to do that. And that it really feels like what we do most of the time, that we get a hunch of what's going on in the data, but we're crossing our T's and dotting our I's, right? But there'll be all these twists and turns along the way. So if you're going in either as a career or within the context of a single project, figuring that you're just going to get a book off the shelf or copy and paste some code from GitHub and everything's going to be cookie cutter, you're in for a surprise.
Got to get comfortable using a compass, not a map, right?
Yeah, I like that. That works. Yeah.
Talk to us about this skill of cognitive empathy. What does this mean?
This is one of the fun examples to share in the course, but it's also one of my favorite things about doing this kind of work is that we're always trying to solve people problems with the math that we do in data science. And the reason that that's the case is that, majority of the time, there's some kind of customer that's involved. But even when there is no customer involved, like people might think, if we're doing predictive maintenance, then, it's more an engineering challenge. Not really true. People are using the machines and repair people are doing repairs and, accidents can be made. Someone was just sharing an interesting example with me where one of the things they look for with this kind of Internet of Things data that they have is that people sometimes brush up against this thermometer. He was describing it verbally, so I've never seen it, but people will sometimes brush up against the equipment and that will cause a problem. So they're trying to see that in the data. But That's what I mean. You have to think like you're the repair person. You have to think like you're the customer to understand what's happening in the data. So I'm such a fan of this that I am somewhat notorious among my colleagues. They think I'm somewhat crazy, that I'll want to spend a half hour on projects listening in on the call center, or going to, if it's a retail kind of a thing. I might want to go to the store and just walk around for a half hour, just simply to understand what are the people things that are generating this data. And it really helps me analyze the results and build a good model.
100% agree with that. I remember, I've been in my current company for almost a year now, and I started working on a project and just first kind of just dug into the data, started building my models and stuff. And eventually, after my probationary period was over, I was able to fly to our other office where the people who'd be using my model were in Atlanta. So we got a chance. I spent like 2 days just sitting with them, watching them how they work and how they're going through their decision process, because I'm trying to model their decision process. And I came back, and just the insights I got from that, I was able to build a model that was just so much more better than had I not done that.
Yeah, absolutely. And there's another aspect to it too, is you have to have cognitive empathy when you deploy, because you have to reflect on what's going to, how is the sales team going to react when the order in which they reach out to customers is determined by the model or something like that, or the priority that a particular customer gets is determined by the model. How are they going to react to that? So you have to really be able to think not only like your customers, but also the end users within the organization.
A lot of people break into data science. They hear it's the sexiest field. They see the pay scale, and obviously we get paid a good amount of money, and they get drawn to the field for that reason. Talk to us why it's important that we have a commitment to our craft.
Well, I just can't imagine that they're going to enjoy it over the long haul unless it's fun. Think about all the other careers that folks do that when people think their folks want them to be a lawyer or something like that. Think about all the people with law degrees that aren't doing the law because their dad was a lawyer or whatever, and they felt pressure to do it. So I haven't met too many people that became data scientists because their parents made them become data scientists. But I agree with you that the draw because of the income is there. But I think it's ultimately the same. If you're choosing the career for some external reason, you're not going to stick with it, and you're probably not going to do your best work, especially since it's endless reading. I've considered myself lucky. I mean, this has been a stressful year for all of us, let's face it, with COVID. I mean, our schedule's been turned upside down and so on. But I've been able to, get books off the shelf and look things up that I've been meaning to for months or years. And then finally I'm here, because sometimes I would go on trips for weeks at a time. Now, how many books can you bring with you? So if it wasn't on my laptop, I probably wasn't going to read it. A typical year, I always made sure that like 4 to 6 weeks a year, believe it or not, I would be not just speaking at a conference, but sticking around for a few days and stuff like that. This year, I've probably been able to do twice that because I've had so much less time standing in line at security. So that's the other thing. If you're not committed to this as a career, how the heck are you going to keep up with all the learning that's required, even at year 25 or whatever year I'm on?
So one thing I absolutely love about this field is the lifelong learning. You have to be that lifelong learner to really thrive in this field. Another one of these skills that it's really been core focus about what I've been studying the last few months is persuasion. There's a lot of great courses on LinkedIn Learning for persuasion. I've been getting heavy into a lot of Robert Cialdini's work, and this is a fascinating thing to me. And I think it's a critical skill for data scientists to have. Talk to us about this. Talk to us about persuasion. How can we be more effective with our persuasion skills in data science?
I was reflecting on something similar earlier today. I think we all do this. You're driving and you're running errands. Sometimes just alone in the car, you'll do some of your best thinking. And I was thinking, how have I learned some of just the basic business knowledge that I have, and how would I recommend that others do it? I think it's somewhat related to cognitive empathy in this way, right? You have to be able to think like the VP of marketing or the COO or the senior VP of maintenance or what have you, right? But then how the heck are you going to do that if you're, late 20s, early 30s, starting out in your career, how are you going to do that? If I had had resources like LinkedIn Learning and stuff like that when I was in my late 20s, because I definitely didn't. I mean, it was back, you'd spend $500 for a couple of videotapes to come to you in the mail if you wanted to do, something like that. I think as time permits, a little bit of basic accounting spreadsheet type stuff, not like Excel, like how does senior management think when they're like working like a spreadsheet? And what's cool is with everything online now, you can find courses like this. I think part of it is that, you have to be a good presenter, you have to do all those things, but part of it is understanding just a little bit of how all these VPs and how these C-levels think. And when I was starting out, it really had to be trial and error and school of hard knocks. But I think now you actually could. Just a week ago, I was exploring a particular issue of the natural tension between sales and marketing, because sales has short-term goals that they have to meet, and marketing has long-term goals that they have to meet. So I was thinking, wow, I wonder if there's anything on LinkedIn Learning on that. And sure enough, there was a 45-minute course on how to get sales and marketing to work together, right? So if I were a young data scientist all over again, one of the things I think I would be doing is trying to give myself the equivalent little bit of MBA type knowledge here and there, not because I need it directly in the project that often, but because I need to communicate my data science models and their purpose to people whose lens is MBA stuff.
Learn to build, learn to sell. If you could do both, you'll be unstoppable, right?
Yeah.
So you've got a course that just came out focused on the most important part of the CRISP DM lifecycle, the data understanding. Talk to us about this.
Yeah, I'm really proud of this one because one of the things that I'm proud of is that, that they let me do it. Because think about it, as a potential author, LinkedIn Learning has an interesting model because it's heavily curated. So typically they reach out to people that are already established in one way or another. In my case, the books that I had written. But this is not the kind of course typically that would be a first course that an author would do. Okay, because it's somewhat going out on a limb to do 4 hours on this topic. But this is why I was so passionate. I'm thrilled that they let me do it. Is that we were talking earlier about what most people do is they jump to kind of that insight step. So they explore the data, trying to get these interesting insights, then project stops. Well, if you think about CRISP DM, you've got business understanding, then data understanding, data prep, and then modeling. So in my experience, by the time you get to modeling, you're about 85% of the way done. So what I cover in the course isn't just exploring data. It's how to do a proper assessment with a very specific goal in mind, which is what is going on in the data that I need to correct during data prep in order to make the maximum model. So if it's true, and I certainly believe it is, that data prep is more than half of any of these projects, data understanding is critical because it's how you plan the data prep. Data prep is not just cleaning. It involves all kinds of other things like feature engineering and so on. So that's why I'm so passionate about this one. I'm thrilled that they let me do it. I could have also done 4 hours in data prep, I'm sure, and that's also a super important phase. But this is the ignored phase. No one talks about this. They probably just think it's the same as data visualization, which it's not. It's very specific things to kick the tires, so to speak, so that when you get to the modeling phase, you're ready to go.
I'm really excited to get through this course. I'm looking forward to it. I'll probably spend some time early next week getting through this. Talk to us about the role that skepticism plays in this part of the life cycle.
Well, boy, that's an important one, too, in non-technical. I think that's where the stats training comes in. I was mentioning earlier that one of my favorite questions that I would ask, let's say, an applicant if I was interviewing was, tell me about a time that the data seemed to tell you one thing, but it turned out to be something else. That's really what the skepticism skill is. And what it comes from is thinking about what is the journey that the data took to get to me, and is there anything that could have happened to distort it, right? But people assume that if there was no explicit source of bias, if there was no mistake that was made, that therefore we can trust the data completely and we have nothing to worry about. And it's not true, because we still have sampling variation, right? People think that in machine learning, we don't have to worry about that because you have, quote, all the data. You never have all the data, because, even if I have all the data in the data warehouse, the data that's in there has gone through a journey, and I certainly don't have the 2021 data as we speak here in 2020. So I still have to understand basic concepts like confidence intervals and so on. So I have to recognize that the data may be seeming to indicate one thing, but it's not true. We're in political season. So the classic example is that, I've always been a fan of 538, which is the website actually, Nate Silver's book was over here because somebody was just asking me about it. But Nate Silver, who runs 538, doesn't do polls himself. He consolidates all the polls. Now, the reason I'm bringing this up is that during election season, the newspapers will report whatever poll came out last night, and they'll fluctuate. So you can get dizzy with, wow, it's leaning one way or leaning the other way. But when you consolidate all those things and you do more meta-analysis and the bootstrapping and the fancy stuff that they do on that website, you get a more level-headed sense that the polls aren't going, the polls are just one data point that can be measured. That would be the kind of thing about skepticism, is that don't let yourself get whiplash with little changes from day to day. Your business is not suddenly succeeding or failing every hour. A lot of it's natural variation in the data, and people with stats training understand that.
I absolutely love that. That is definitely turning into a quote graphic. So last formal question before we jump into a quick random round, and it's 100 years in the future. Keith, what do you want to be remembered for?
Well, even though I'm proud of the work that I did on it, I have a feeling that I'm not going to be remembered in 100 years for SPSS for Dummies 4th edition, because the life cycle of a book like that is probably more like 3 to 4 years, right, for the next edition. So one thing that I've wanted to do more of, and that this crazy year that we're having has really caused me to reflect on, is more the analytics management and more the philosophical side of the business, which you can probably tell that I enjoy. I was a philosophy minor. Actually, I somehow managed to squeeze in a philosophy minor with a computer science degree. And if I write a book in that area, either analytics management or philosophy, I think that might at least give me a chance of 20, 30 years from now. Fingers crossed that it would be anything as wonderful as 100. Yeah.
What's your philosophy of life? Do you have a particular school you subscribe to, or some branch that resonates with you?
Well, of course, when folks think of philosophy, they often think of, that side of philosophy. I was always more into epistemology, which is study of knowledge. So I get super fascinated with Turing. There'll probably be like two people that hear this that will be also fans of this guy, Wittgenstein. I don't know if you've ever heard of Wittgenstein. He's probably a bit obscure, but anyway, I'm like a huge fan of him. But on the more kind of philosophy of life type stuff, I'm a Jung fan. I'm kind of into the book thing, and I've got Jung's collected works downstairs. That all started because a lot of people, I'm sure, have heard of the MBTI, and Isabel Myers, who wrote it, had a collaborator late in life, like the last, 20 years of her life or so. And her collaborator was someone that I had a chance to meet when I was still a freshman in college, and knew her quite well for the last several years of her life. So for me, the MBTI isn't like a paper and pencil thing. It's like the whole Jungian thing. So that was for about 10 years. I did a lot of research on that and the instrument. That's a whole nother story. But the more philosophy of life stuff, I'm a big Jung fan.
Awesome. I think you should connect with Giuseppe Bonacarso, who's also a data scientist. He's written a few books for Pact, and he's also heavy into the philosophy. I think you two together writing a philosophy book would be an awesome remix. So
I'll have to check that out. Yeah, I've enjoyed the session, the episodes that I've heard, but I haven't heard that one.
Yeah, that one's it's releasing next week, I believe. But I'll introduce you guys on LinkedIn as well.
That's fabulous.
So let's jump into a quick random round here. What do you believe that other people think is crazy?
Well, we've talked about it, but the answer that comes to mind is that, the goal of projects is not actionable insights, because I'll get silence when I say that at a workshop until I'm able to explain myself. It's like everyone's shocked.
You could have a billboard placed anywhere in the world. What would you put on it?
Oh, I was reflecting on this kind of thing. Where did I put it? It was a Jung quote, actually. We were just talking about Jung. It was, but how did Jung himself phrase it? I'm sure I'm going to mess up this quote, but the best thing that can happen to you in life is to be yourself. Something very close to that. Yeah.
I love that. What are you currently reading?
Oh, I'm the kind of person who reads like a dozen things all at the same time. But there's two books that I've been somewhat in the grip of this year. AI Superpowers by Kaifu Lee. It was written a couple of years ago, but I think that's really powerful because he kind of explains the philosophical difference between how Silicon Valley handles AI and how the companies he works with in China treat AI. And I find that to be really powerful. And then the other book is a little bit more technical, but I'm really in the grip of it too. The Book of Why by Judah Pearl, which is about causal inference, but written for a general audience and really, really something.
Yeah, I've heard great things about that book. It's definitely on my list of books to pick up. Next few questions, we're going to go to the random question generator.
Okay.
All right. What's one of your favorite smells?
Oh, this is, I get this from my best friend. He turned me on to this, and he's right. Petrichor.
All right.
The smell after a rainstorm. If he hears this, he'll get a kick out of that.
Oh, okay. I didn't even know that had a name. Awesome. What fictional place would you most like to go to?
The answer that comes to mind is I kind of got into Game of Thrones there for a while. And although it's a real place, the pictures of the capital city are just amazing. So I'm hoping that I'll go to, it's in Croatia, isn't it, that they filmed it?
Yeah, they filmed a few places in Croatia. Dubrovnik is where the King's Landing was for the later seasons. They've also filmed in Split as well.
Yeah. So I'm probably cheating, but my answer is Dubrovnik. And I've been to over 50 countries, but I have not been there. Oh,
Croatia is absolutely beautiful. Yeah. We did a road trip all along the coast, starting up top in a city was called Pula, and we drove from Pula all the way down to Dubrovnik.
This is just cheating a second time, but I'd also love to see the Hobbit town.
Oh, in New Zealand.
That apparently they preserved and didn't tear down, right?
Yeah.
And I have been to New Zealand. It's fabulous.
Oh, it is. When was the last time you changed your opinion about something major?
When I was college age, I was a Reagan fan. So I was a bit, a bit conservative. Was that because I was military? Who knows, right? Mm-hmm. But since then, I am not.
Last question here from the random question generator. What was your best birthday?
Oh, I've got kind of a fun answer for this one. When I was approaching 50 and wanted to do something fun, I arranged for a rental of like 4 cottages in Italy and rented out all of them so that a bunch of friends could go. But I couldn't get them on my actual birthday. So it turned out to be like a year before. So long story short, for like a year and a half, I had a series of birthdays because I was celebrating with my friends in very different places all over the world when it was convenient to hang out with them. So it never ended up being one day. It ended up being like a year of birthday celebrations, which was a lot of fun.
Oh, that's absolutely awesome. So how can people connect with you and where can they find you online?
Well, LinkedIn is absolutely the best way because in particular, since I've started doing the courses, I'm on there almost every day. So that's a fabulous way. So if they'll just simply follow me on LinkedIn, that's an absolutely great way to stay in touch. And if folks choose to check out the courses, I hope they do. LinkedIn has added this Q&A feature. Mm-hmm. So what's fabulous about that is if somebody asks a question about one of the courses, everybody can see it and it becomes a conversation. So that's a great way to be in touch as well.
Thank you so much for taking time out of your schedule to be on the show today. I really appreciate you being here. Thank you.
I enjoyed it very much.